A. Okay, so let's say we have A is equal to -1. So which is negative, right? Okay, and B, we have non-integer, which is in fraction, which is 1/3. Okay, and you see that C here, we return into the complex root. Okay, see here, the power function returns the complex roots of A. Okay, because -1/3, sorry, 1/3 to the power of -1. 1/3 to the power of -1. Okay, so you will get like this. Input into the imaginary number 0.5 plus 0.8660i. Okay, we have a complex number here, imaginary number. Right. You see it? Okay. So next is, okay, we want to do a root function. Okay, we want to do a root function. Okay, to have a real root, we use the nth root function. Okay, what is nth root function? Y is equal to xn. Return the real nth root of the element x. Okay, both x and n must be real scalar or always array of the same size. And if an element x is negative, then the corresponding element in n, okay, must be an odd integer. Okay, it must be an odd integer. So let's say we put as C is equal to n root A3. Okay, can you copy it then put in your MATLAB? Okay, you will get -1. Okay, now, okay, so this is, let's say we have n value. Okay, we have n value 5, 3, 1. Then our root is -8 and n. So 5 square root -8. Okay. Yes. Sorry, -x square root of 5, -x square root of 3, -x square root of -1. Okay, can you copy it and put in your MATLAB? Okay, can you copy it and put it in MATLAB? Okay, you will get -5.157, -2, and 0.125. You can check it using your calculator too. Okay. Okay, now we're going to get more complex. Okay, we're going to get more complex exponential function. Okay, but for the time being, okay, okay, I want to demonstrate root function graph. Okay, I want to demonstrate root function graph. Okay, please copy, okay, my coding in Teams. Sorry, my coding here. Okay, I think faster I copy it and put in Teams. Okay, I have put it in pips. Okay, so here my value of x is between -5 until 5. That has 1001 value. Okay, and after that, I square root all the value into 3. Okay, I square root all the value into 3. So -5 square root 3, -4 square root 3 until 5 for 1001 value. Okay, let's say if you want to look at the value of y, you can click this. Okay, you can see the value of y. Okay, you can see the value of y here. Okay, double click y. Okay, now, but that's not my concern. Okay, but I think the figure here is not there. Okay, so now then I plot x and y is a root graph. Okay, x limit, y limit. Okay, here I want to make it the tick. What is tick? You know the x label? You know the x label? So I want to label it. Okay, I want to label it. Okay, you see here? Okay, the tick here for x is, you see, -5 to 5. So tick here, -5, -4, -3 until 5. But my y tick, okay, my y tick also from -5 to 5. Okay, also from -5 to 5. It's not, wait. Okay, my what? Okay, my tick also -5 to 5, but okay, if you see that the limit here, okay, the limit here is minimum y minus 0.5, maximum y plus 0.5. So that's why, okay, here you don't see until -5 to 5. Okay, you didn't see from -5 to 5 because we have put the limit, the minimum minus 0.5, maximum plus 0.5. Okay, so if you don't put the limit here, okay, so if let's say you didn't put the limit here, oh, it's even shorter. Okay, by default it will use the MATLAB function. Okay, I used 2022 before. Usually it will appear there, but it's 2024 version of MATLAB. It will cut it short. Okay, so this is how you use a root function. Okay, this is how you use a root function. Okay, next is, okay, this is root function for this question. Okay, now we're going to exponential function, okay, where we're going to use cosine and sine. Okay, y is equal to exp. Exp is in MATLAB, is exponential for each element in array X. Okay, so for complex element, which is X plus I imaginary number multiplied by Y, it returns the complex exponential. Okay, it will return in complex exponential. Okay, so so now we are going to plot exponential function. Okay, open your MATLAB. Okay, I will share it in Teams also. Okay, here my x is between -1 until 1 that has 1001 value. Okay, so exponential function here I put as 3 times exponent 2 to the power of x. Then after that I plot xy. Okay, this one also limit minus 0.3 plus 0.3. Okay, it's up to your preference. Okay, then we use hold on. Okay, we use hold on because we want to set the marker. Okay, because we want to set the marker. Okay, then we have to run section. Okay, so you see here, okay, I have a value of 1 marker point, which is x is equal to 0 and y is equal to 3. Because 3 to the power of 0 will be equal to, sorry, this one is x, okay, yeah. To the power of 0 here is equal to 1. So 3 to the power of 1 is y is equal to 3. So this is my marker. Okay, this is my marker. I put 1 point here. Okay, let's say I want to put my x marker from 0 to, this one is 0 to 1, right? Okay, maybe I want to put 0 to 0 0.5. Okay, so 0 to 0 0.5. It's not appear here. Maybe I should like this one is -1 to 1. Okay, so let's say I put says I want to do 0 until 1. So I have 2 marker here. X is equal to 0 and y, sorry, and another one is x is equal to 1. Okay, so this is how we do it. Okay, you can change the shape of the marker, okay, to become any other color that you want. You can also specify the line to be any color that you want, and also the width of the line. Okay, any question? Any question? Okay, don't worry. I will share the one that we in the class. Okay, but not all. Okay, but not all, because I want you to participate in class. Okay, the code in Moodle. Sorry, yesterday, last night I just share the lecture coding because I forgot. I thought that I have upload in Moodle, but it's not. So last night I just did it from the yesterday, the day before yesterday coding. Okay. Uh, any question? No? Okay. Open your Power Apps. Okay, to next week, I will continue with logarithmic function. Okay, next week, I will continue with logarithmic function. Okay, as wait. This is the attendance code for today.